All right, hello and welcome. So before we begin, I'd like to take a moment and just say thank you for choosing to come to this session. This is integrating Jira Software Cloud with the AWS Code Suite. And as Mel pointed out, my name is Jay Yeras, and I'm a Partner Solutions Architect for Amazon Web Services. Now, my work at AWS is with DevOps, particularly with the partners that are in that space, and helping them build integrations, tight integrations to our AWS services. So I get to work with terrific partners like Atlassian and various others. And I may not look it, but I have over 20 years experience in this field. I know, it sounds crazy. Trust me, it's true. So I started in humble beginnings. I started out as a sysadmin for HP UX. Quick show of hands, how many people even know what I'm talking about? Okay, a few of you guys. All right, we're in the same age group. Yeah, I worked on R-class HP 9000 servers, and when I think about that, I get shocked at how long ago that was, but here I am. So I've worn many different hats over the course of the years. I was at one point a professor. I tried my hand at being an entrepreneur. I was a DevOps engineer. And the more recently, for the past 2.5 years, I've had the opportunity to work at AWS, which has afforded me this awesome opportunity to come to events like this, share what I know, and inspire folks to build terrific solutions on AWS. So I've done a few of these events, and I always like to start things off by level setting. And I know that when we go to these types of events, there's a ton of information being thrown at you. You have titles and abstracts, and I like to have expectations set accordingly so that you're all satisfied with the content we're going to provide. So with that, this is going to be a technical presentation. So if you are a technical person, a developer, a builder, anybody that's comfortable with cloud architectures, you're in the right place. If you're not, that's okay. Hopefully you'll find some of this material interesting, but be fair warning, there's going to be some sections that might be a little bit dry for you, but I'll do the best that I can to engage you and hopefully inspire some interest in the topics that we're going to talk about today. So many of you are here because you have an interest in Atlassian's issue and bug tracking project management software, Jira, right? We all agree with that? So you may also have had exposure to some of the AWS developer tools or are interested in learning more about those if you haven't. Just quick show of hands, how many folks have used AWS or are using AWS? All right, fair number of you. And how many of you are also builders where you're building apps on and selling them on the Atlassian Connect, Atlassian Marketplace? Okay, great, awesome, good distribution. So if you're just curious, that's fine too. You'll get some knowledge out of this as well on both how to host applications on AWS as well as how to build integrations to our developer tools. So every time I talk with customers, specifically around DevOps, and others can share the same information at AWS, one of those conversations typically end up gravitating towards a common theme, and that theme is, how do I get prescriptive guidance from you? People are tired of, just tell me what you're doing and we're going to make it all work. So they want a very opinionated approach to how to do this, and I believe semantics are important. So again, in our industry, we are flooded with a lot of jargon, acronyms, and things like that. So I want to offer you prescriptive guidance on an example use case, which was how I built an integration to our developer tools and how I hosted that on our AWS cloud. So the information that I'm going to share is going to solve for that specifically. I want to answer the how do I or the what's the best way to questions that I often hear. So it's going to be opinionated and it's going to be prescriptive. So I've broken down what is actually a full day workshop. It's about 6 to 8 hours. And I've tried to condense that into this 45-minute session. So that wasn't easy. So bear with me as we're going through this. If there are any items or any areas that you feel weren't covered in enough detail, there is a corresponding workshop that goes with it that goes into that detail. So I'll share information with that in a few slides. But I've basically broken this down into 4 categories. So we're going to start out with the source. This is the beginning, the foundation of how I built the app. Then I'm going to go into some of the AWS services that I use to architect the solution. And then I'm going to talk a little bit about the workflows that I applied as part of that and share some techniques. And then lastly, I'm going to cover in detail what the actual integration looks like. And yeah, we'll get started from there. So let's dive right in. We're going to get started on how to build your application. So in the following series of slides, I'm going to discuss the code base that I used to create this project and the technical details for the framework that I selected and some of the considerations that I had to keep in mind from a networking perspective, as well as examples of how to compile and run this code. So in this project, I started with the Atlassian Connect framework, and specifically, with the Spring Boot version of this. So you can write your app in any programming language that you choose, or use any web framework that you'd like. But for my purposes, I started out with the officially supported version of this, which again was that Spring Boot starter kit that's available in Atlassian's Bitbucket org. So at a high level, the Atlassian Connect app, for those of you who are not familiar with it, is going to run as a web application, and this is going to operate under HTTPS. So we're going to need some supporting infrastructure in order to host this application, right? And I'm going to talk a little bit about the specifics of that in the next few slides, but your app is going to be configured to serve specific modules. So we take the source code, we add some modules to those, and those are going to allow you to interact with your Jira Cloud UI. So from an end user's perspective, the effect is that you're going to have an application that's going to be fully integrated to the cloud, the Jira Cloud. But under the hood, your Atlassian Connect app is going to provide for secure requests to your Jira Cloud REST APIs, and it's going to register for secure webhooks from Jira Cloud. So love it or hate it, Java and Spring are really not going to go anywhere. I know when I talk to developers, there's always a lot of opinions on what are the best frameworks, and everybody has their preferences. So this is growing at a fast rate, and this was adoption of Spring and Java. It continues to grow, and I chose this framework mainly because of the architecture that I had in mind and how I was going to deploy this. It seemed like the logical choice, and again, the fact that it was officially supported by Atlassian was another consideration. So it's still worth mentioning, though, that I want to detail the key points to building this integration as part of this talk. So Spring Boot also had the value of allowing me to externalize some of my configuration information. So I'm going to cover that in a little bit of detail in the next couple slides. But in the case of our Atlassian Connect app, we're defining this in our application YAML file, which you'll find within the application source directory. So you have on the screen an example of what that application YAML file looks like. And I've gone ahead and highlighted some of the relevant variables, like the port, as you can see, a base URL, and then some authentication information. So what you see on the screen here is an example of the Atlassian Connect JSON. So this is the file that is our app descriptor file. And we're including general information in this file, such as the app vendor, the licensing, some lifecycle registration information. But this also includes the various modules that we want our app to service, right? And I'm not going to go into details on specifically the syntax for this, and I apologize if it looks really small, but it's hard to kind of include some of these files in slides. The documentation for this on the syntax is available on Atlassian's documentation pages, so you can go afterwards and take a look at that. I've also included it in that workshop that I mentioned. So Atlassian provides a standalone validation service that's part of this. So if you guys worked with JSON before, you know that an extra comma or something like that can really affect what you're doing. Then you have to go figure out where it is. So they have a validation service for the app descriptor available on their website. So I encourage you to be aware of these tools, use these tools as part of your process, and test every step of the way. So I wanted to call out one other thing with respect to this file. So recall a couple slides ago when we covered the application YAML and externalizing parameters. So I've gone ahead and taken two of these, the key and the base URL, and I'm passing those into my descriptor file as well. So the value in this obviously is define it once, reference it later and elsewhere, and then not have to worry about other occurrences of where you define those values later. So I wanted to talk real quick about the requirements from a networking perspective. So these are going to be very categorical. So one of the things that I experienced as I was working with this is that self-signed certificates are not viable or supported in any fashion, even if you're working on a development environment or a test environment, or you're just trying to prototype some of this. So you're going to need to have a valid SSL cert from a valid CA in order to register your application with the Atlassian Marketplace, or even if you're going into developer mode within your Jira instance. So since traffic consists of sensitive information, like those credentials that we saw a little while back, I think we all agree that having a secure protocol like HTTPS is required, right? So there should be no argument on that. So the question then is, well, how do I solve for this if I want to prototype or I want to just play around with this and I don't have an SSL cert? Like, for example, a training environment. So I have a solution. So the solution is to use a third-party service. So I used ngrok. Anybody familiar with ngrok? Everyone is. All right, so this is all old information for you. So basically how this works, and just indulge me, is you're going to download and run your application, and you're going to specify your port, and that's it. You're up and running, right? And this is going to allow your app to connect to the ngrok service, and then you're going to accept traffic. It's going to relay that information back to the local process that started that request, and everything's good. So this allowed me, in a long-winded way of saying, it allowed me to kind of bypass the SSL certificates and be able to run my app and then test it out on my Jira instance without having to set up and provision certs or anything like that. So again, the steps are outlined here in terms of what you would use. So ngrok's available in NPM, so you can just do a simple NPM to install your app and then just run it, and there you go. Now, the point that I wanted to highlight here is really in the last section here. So once ngrok's up and running, you're going to get some forwarding URLs that are going to be available for you. And the one I wanted to call attention to was the one with your HTTPS address. So I'm going to use that later on as I'm going to pass that into some of the other configurations I'm going to use when I deploy and host this. So we're ready to test our application at this point, and we want to see if it's actually running. So we've taken the application YAML file, we've taken the app descriptor, we've parameterized those values, defined our modules, and now we want to see if this is actually going to work. So in order to do that, we're going to have our environment up to date, and Java 8 and Maven are going to be some of the prerequisites that you're going to use, so make sure that you have those available and updated in your environment. So from our IDE, we will quickly test out if we've set things up and correctly and run our application. So we're going to leverage the Spring Boot Maven plugin to quickly compile our code and run the app. Now, we're going to be passing in several parameters at runtime when we do this, and these are going to correspond to those that we've defined in our application YAML file. And we're also going to use the AWS CLI for some of these, because there's a step that isn't covered here, but I'll explain, is when you create your Atlassian user and your credentials, you're going to want to store those somewhere. So in my case, since I'm running this on AWS, I'm going to take advantage of some of our services like Secrets Manager to provide for secure storage of information like this and be able to then reference that information and retrieve it at will with security in mind. So we can quickly see if our application compiled right from the terminal, right? If there's anything wrong, you'll see the result, and everything succeeds, your app is up and running. So you're going to get a base URL, or rather, remember that base URL that we were talking about with ngrok? I can also test this by taking that base URL, or the forwarding URL, and then just opening up a web browser. What I will expect to see if the app is running is what you see on the screen. It looks familiar, and it should, because it's your app descriptor. So once your Connect app is running, hitting the entry point for the app is going to produce an exact copy of what your app descriptor looks like. So you have an additional way of testing if things are up and running. But we haven't done a full test yet because we don't know if the modules that we've defined are actually working. So we want to make sure that things are communicating properly from that end as well. And I'll talk a little bit about how you're going to do that too. So we've covered the technical details of building our app at a high level. I talked about the application YAML file, and I talked about your app descriptor and where to get the source code for this, and some basic steps on how to run the app. I wanted to take a moment now and talk about some of the AWS services that I used in order to host the app. So there's two parts to this talk. It's how do I host an Atlassian Connect app on AWS? And then the other part is now how do I integrate Jira Cloud with AWS developer tools like Code Suite, and, code pipeline, code commit, and code deploy, and things like that. So I'm going to kind of decouple these things and then talk about them. But I'm also going to shock you with this crazy reference architecture, right? It's one of those things, everybody loves to see them. It's super, detailed and probably not the best thing. If there was ever an anti-pattern for presentations, this would be it, right? But that's okay, because this was my shock and awe. I wanted to communicate that this is actually going to be a complex thing you're going to set up, right? A lot of moving parts here. I'm going to go step by step, and I'm going to highlight what some of the key services are that I'm using. This is also available on that workshop website, so you can download it or take a look at it there later on. But some of the things I'm going to cover are going to be AWS Fargate, for example, our fully managed orchestration service for running container-based workloads. I'm also going to talk about ECR and how I leverage that to store my container image, because again, I'm starting out with a Spring Boot app, right? And the reason I wanted to do that was because I wanted to eventually create my jar file and then have this run as a container. And there's a whole other layer of this, which is the networking layer. I'm not going to go too deep into the details for that yet. There's going to be a VPC. There's going to be some public-facing network load balancers. Obviously, there's going to be some certificates. For that, I'm going to leverage our other service, Certificate Manager, to be able to provision those. And obviously, Systems Manager for parameter store to store some of the secrets, as well as Secrets Manager. So I'm using a combination of those two. The other part of this too, and this is more specific to how you're going to build and maintain your application, is with using our developer tools. So the developer tools consist of a source code repository, which is code commit. It includes a CI/CD pipeline, again, all fully managed, which is code pipeline, code build, and then the integration piece, which is going to be Lambda based. So there are going to be 2 Lambda functions that I'll go into detail, and those will be triggered off of CloudWatch events. So all of this information is captured in that diagram. So I started out in this project, working on this project, and one of the first things I did was use AWS Cloud 9. Are any of you familiar with Cloud 9? A few of you are. So for those of you who are not, Cloud 9 is our cloud-based IDE. And you might be wondering, what is a cloud-based IDE? Well, Cloud 9 offers you a web browser that also includes a terminal that gives you direct access to our AWS environment, and it also includes an editor. So under the hood, it's really an EC2 instance, and it follows with all the networking that you would expect from provisioning EC2 on your environment and things like that. But it allows me, I travel and I bring my laptop, but I also work on other computers. So it allows me the ability to be able to just have a development environment that's going to be consistent across the board, because all I need is really the web browser. So from a training perspective, since I mentioned this talk was based off of a workshop, this was an ideal solution to start off with, because it level sets things and I don't end up with that issue of it's working on my machine, why isn't it working on yours, right? I'm giving you step-by-step instruction and helping you build an environment that's going to match what I'm using to build. From an organizational perspective, and not to make this sound too much like a salesy pitch, right? What Cloud 9 offers is the ability for multiple developers to share and collaborate code in real time. So for those of you who've never seen this, this is a visual of what a Cloud 9 environment would look like. So in this example, we have some code in the Cloud9 IDE's editor that multiple developers are working on together and collaborating. It includes, again, that terminal, and it also includes chat functionality. So again, there was an advantage in doing this, and part of what I wanted to capture in this was how to use our services together to build fully automated CI/CD pipelines and focus on the developer experience first. So our integration is going to necessitate some supporting infrastructure. Because we're using the Atlassian Connect app and its framework, that's going to have to be hosted somewhere, right? So I've chosen, as I mentioned before, to start with Spring Boot app. This was a good candidate for my container-based workloads. And of course, that implied that I needed to have container images. And therefore, Amazon ECR was the obvious choice for me, because I have the ability to securely store my container images, which I'm going to build. And I also have the ability to integrate this easily into other AWS services, like the ones I'm going to cover in the developer tools. So one of the things I love about our AWS services is the pay-per-use pricing. So all the services that I'm covering as part of this talk have no upfront commitments or fees or anything like that. You literally are paying for what you're consuming. So there are many tools out there for CI/CD. I know that people have their preferences in terms of which ones they'd like to use. But for these examples, again, I focused on our AWS services. So I start out with Code Pipeline. And again, you have no upfront fees and no infrastructure to manage, which is terrific. I get out-of-the-box integrations to a number of different AWS services, and I also have pre-built plugins to a lot of popular third-party tools, like Jenkins, right? We all love Jenkins. I like Jenkins too. So my examples are going to be built off Code Pipeline as well as Code Build and Code Commit. And last but certainly not least, I mentioned that I had container workloads and I want to run these, right? So I'm running my container workloads using AWS Fargate, and this was a natural choice because although I started out as a sysadmin, I really loathe having to maintain operating systems and do patches and things like that. I kind of want things to be in easy mode. So AWS Fargate is a launch type for ECS, our container service, that is fully managed. You have nothing to worry about. You have no cluster management, no servers to provision. It's all taken care for you. So you simply work on your apps and deploy them, and that's it. It's magic. You only pay for what you use. So those are mainly the AWS services that are going to be used as part of this solution, right? And I wanted to spend some time now on some of the patterns for provisioning these services. So I wouldn't shock anybody in this room if somebody were to say, Jay loves automation, right? Because I do. I love automation. I like things in easy mode, and I like to do them once and not have to worry about it. So just to kind of recap what this workflow looks like, I start out by launching Cloud9 into my AWS account, and that's the basis from which I'm going to then provision everything that I need in my environment. I'm going to set up my Cloud9 instance with the dependencies and the prereqs that I need to build my app. I'm going to git clone from my repository where I have not only the source code for the Atlassian Connect app, but I also have some CloudFormation templates that I've included. And I promise you I'm going to share those with you. And then from there, using the AWS CLI, thanks to the terminal that's in my Cloud9 instance, I can just start going ahead and provisioning some of this infrastructure that I'm going to need in order to develop and maintain and host this application. And that's going to start with ECR. I'm also going to deploy my Fargate cluster. And I'm also going to deploy Code Commit and Code Build and Code Pipeline, all with a click of a button. And then I'm going to take this and I'm going to integrate it with Jira Cloud, and I want to get some perspective on what's going on in my pipeline. And for that, I'm going to leverage AWS Lambda. And I'm going to have 2 Lambda functions that I'm going to map to each of these respective services. So there are many layers in these examples, and that was intended to be a pun. So the examples are intended to guide you through the various stages of manually provisioning these resources and running your application to automate the steps that are going to be needed for setting this up with infrastructure as code and some application development techniques that I'm going to share. And one of these techniques is multi-stage builds. So how many folks are comfortable with multi-stage builds and use them today? A small handful? All right. And the rest of you are shy and don't want to admit it, but okay. Maybe you're not. But in this example, I'm going to share with you a copy of the Docker file that I'm including as part of this workshop content in that source code. And what I want to highlight is how multi-stage builds work with containers. So again, this is included in the repo so you can reference this, but I went ahead and highlighted here. This example of this Docker file includes 2 stages. I have a build stage, and in that and I also have an application stage. So what I'm doing in my build stage is I'm referencing a specific image that I'm going to use, and that's going to do the work of actually building my application. It's going to do that because I'm also going to copy my POM XML for my Java app, and I'm also going to compile that, and it's going to produce an artifact, which is my jar file. I'm going to then take that jar file, and I'm going to pass that to my next stage, which is going to be my application, and I'm using a different image for that. And I'm also doing a couple other things like defining the port I'm going to use, and again, that's going to reference the one I defined in my application YAML. And it's also going to set the entry point that's going to respond to traffic that container is going to service. So AWS Code Build is another one of those services that I mentioned. That's part of the developer tools that AWS provides. And again, like most of those services, this one too is going to be pay as you go. And what Code Build is going to provide for you is it's going to provide a build environment. And one of the things that's specific to Code Build is that we define the commands that we want our build environment to run based on a build specification reference. So this is going to be yet another YAML file, and it's going to be formatted to include the commands that we want our build environment and Code Build to run. And it's going to be run on our pre-configured environment that we select when we deploy Code Build into our environment. So I'm including another example of what that file looks like. Again, this build spec YAML file is included as part of the sample code that I have created for this workshop and this talk. And I want to call your attention to 3 phases. So in your build spec YAML, you can group the commands that you're going to run in, and they're done in sequential order. And these are logical. So what you're going to do here in this particular case is I have my pre-build. So in my pre-build, I'm taking care of things like setting up my environment. And some of the things I'm going to do there is, for example, authenticate to my Amazon ECR service so that I can have access to that store and be able to store my image that I'm going to build. Later on, and you can do other commands there to prep your environment, like your dependencies and things like that. In the build phase, I'm going to do some of the work that I did before. So if you're following this from the workshop perspective, I take you through the motions of doing this manually from a terminal in your Cloud9 instance. Then I cover how to codify some of this information and use infrastructure as code. And then in this phase of the workshop, what we're doing now is automating some of this by having a build environment do this work for us. So that's captured here. So in that build phase, what I'm doing is taking a Docker file that's going to get copied into that build environment and then running the Docker commands to build my image, tag my image, and then in our post-build phase, the last phase for this build spec YAML, basically pushing that image back into ECR. So now it's stored. So that completes the cycle of my development and maintenance on the application itself. But we still haven't covered the deployment part of it. So whether you're launching your containers on Amazon EC2 or Fargate, both of which are launch types that are available with ECS, you're still going to need to define your application, okay? And for that, we have what's known as the ECS Task Definition. So in my example, I'm including a task definition, and by example, I mean my source code that I'm sharing with you. And this is included in a CloudFormation template because I'm using this to deploy my environment. And in this particular case, I don't really care about modifying that later on. The reason I bring this to your attention is that you have the option of externalizing the task definitions for ECS as a JSON representation, and that's valuable for you if you're looking at making changes to how your app is going to work and you want to take that same approach of infrastructure as code and isolate that from the templates themselves. You can certainly do that. But again, this wasn't really necessary for my example, so I ended up just including it in the CloudFormation template. You really can do either one. So I wanted to share with you what this looks like. So the top portion of this slide includes the AWS CLI commands that I'm using to deploy that template that includes the ECS Task Definition and is going to ultimately provision my cluster. And in the bottom section of it, you have a copy of the actual CloudFormation template as well. And the little arrows are mapping the parameters that I've externalized for this. So in the CLI command, you'll notice that there's some environment variables that I'm passing. Some of those are like the Jira credentials that I'm using for my Jira Cloud, as well as some ECR specific credentials, the port, and things like that. In my template, again, I'm mapping those there. And what I'm doing is using my environment, I'm querying the, let me switch to that slide. Through the AWS CLI, I'm querying Secrets Manager, and I'm capturing that value, passing it into those variables that are then going to trickle down into my templates and then deploy. So I don't have to actually provision them or provide them over the terminal and then send them over clear text over the internet or anything like that. So we're at the final section of this talk, so I wanted to go into a little bit more detail on the integration portion of this. And the core of this integration, if you really think about it, really has to do with sharing of information. So the use case that I'm presenting is kind of iterates on itself, right? Because you're building the environment, and again, it's an exercise. The intent is to give you insight into how the services come together and how they operate. Again, so you can host an application on AWS the right way, and then also so that you can build integrations, not just to Code Suite, but then be able to extend that out and maybe solve for other use cases that are not covered as part of this. So what we want to do is basically have disparate systems providing this information and having Jira serve as our single pane of glass for our development environment. So as issues are being created, you can also correlate those to specific commits and be able to get insights into your build process in your CI/CD pipeline. So in order to do this, you kind of have to map a couple things. And what I have here is an example of one of the pages in that workshop, and there's a reference mapping. Now, this information is available online, and you can look at it, and you could probably search for it yourself because Jira, Atlassian has the Jira REST APIs very well documented. If you're searching the AWS website, you're going to have corresponding APIs that we're using for this as well. And this information, you're going to have to map it. So I've done the hard work for you, and I've included that here. And this is going to become our Rosetta Stone for those Lambda functions. So I mentioned that I used code commit. In that process, when I had my Cloud9 IDE and I had some of this source code, I went ahead and pushed that into a code commit repository that is integrated to code pipeline. So any commits that I push to code commit are going to automatically trigger my pipeline. My application source code is there. It's going to build my app, give it a fresh image, and then deploy this out to Fargate continuously as needed. But in order to get code commit to send this information, we're going to leverage AWS Lambda for that. So what we're going to do is we're going to use a Lambda function that's going to be connected or invoked as part of an event trigger in code commit. This is offered natively in that service. And what we're going to do with that is send data over to the Atlassian Connect app that's running in our environment. Now, with code pipeline, you can integrate with Lambda within pipeline and have Lambda functions invoked as stages within that pipeline. But since I mentioned that we're using Lambda for our integration, the natural thing would be to think, well, why wouldn't I use this integration point as what I would leverage for the Jira integration? The problem I had with that was it seems kind of odd to have an internal process monitoring itself. So code commit has its method for triggering Lambda functions. Code pipeline has a different method, and they don't really match each other. So with code pipeline, we're leveraging Amazon CloudWatch events, which can be configured to do a number of different functions whenever there's a pipeline state change. So because my data that I'm querying off of my code APIs is not going to map, remember that reference mapping, directly to what the Atlassian Connect app is going to use. I needed to use the CloudWatch events to trigger the Lambda function instead, and that's how I approached and solved that problem. So as pipeline state changes, my Lambda function is triggered. And what's happening behind the scenes is that we begin, our functions will map to two modules. Let me rephrase. So what's happening behind the scenes is that as each of these functions are being triggered, each function is going to correspond to each of the respective modules that I define in my app descriptor. So in the app descriptor, in the module section, I have the developer tools module, which I'm aligning to code commit, and then I have my build module that I'm aligning to code pipeline. And then I have the corresponding Lambda functions for those. And what I'm capturing there from those APIs are the commit ID, commit messages, all the relevant information that is required, a required field for my REST API on the Jira side. And I'm doing three basic things in my Lambda function. I query the APIs, transforming that data so that it matches the fields that Jira expects, and then passing those as a JSON payload to my Connect app. And I'm doing that in the response body section of the Lambda function, and I'm using JSON stringify in order to create the payload. So there's an example of this in the actual Lambda function that I used as part of the source, so you can take a look at that afterwards. Now I'm doing the exact same process with on the build module, using those code pipeline APIs, and it's going to mimic the exact same function from the Lambda perspective. I'm going to capture some data from my code APIs. I'm also going to transform it, and I'm also going to post it. In this case, what I'm doing is I'm capturing my pipeline execution ID as well as the execution status. And what I'm doing also is the logic of correlating that pipeline execution ID to my commit ID, because we want to be able to report back on the commit that initiated that pipeline. So this brings us to the end of the talk. And I wanted to take a moment and reflect on what we've learned. And I condensed a lot of information into this session. And I kind of wanted to recap real quick on some of the things that we covered. So I shared patterns for how I approach the source for the Atlassian Connect Spring Boot app and how I made that into a container-based image. I also talked a little bit about the AWS services that I used in order to deploy this app and provide an environment that I can host apps that I'm building, and also the developer tools that I used from the AWS developer tools like Code Commit, Code Pipeline to create that environment for myself. And then I also talked about the Lambda functions that you can use in order to create those integration points between Jira Cloud and our code suite of services. So I also told you that I promised you some sample code. And I do have that. So I have a public-facing version of this talk. And again, this is a full-day workshop. Don't worry, the URLs are coming later. And what this should walk you through is everything that I covered in this talk, and then all the things that I wasn't able to cover because of the time constraints. So I wanted to take a moment again and thank you for coming. I really appreciate your interest. My goal today was to kind of share with you what some of these services were, but most importantly, to inspire you to build